Hello friends, this is Yarrow giving you another little version of the zero force motor. In this instance we're going to be looking at a two-pole arrangement, meaning instead of 4 magnets on the ZFM there are only 2. The reason for that is we wanted to investigate the operation of the ZFM with 2 poles but firing still 4 times, and firing in actuality both in the dead space right here where there is no coil and also within the coil, just to see how the ZFM reacts to it. As usual, the arrangement that we have here is the normal TET sensor, which is the amperage sensor, and behind it is the zero force motor Bedini coil circuit board, which controls the firing. We've also added another little piece to the puzzle, which is the oscilloscope that you see there on the left. Now, what we're going to do is do a short run. This particular arrangement in parallel mode for the coils is the resistance value is very low, about 1.5 versus the 6 in a normal arrangement. But that's the parallel mode, it can't be helped. And there are a couple of interesting things that we'll point out here. We're running this on 24-volt batteries. Reason being is that the batteries smooth out the back EMF and reduce the hash on the oscilloscope. So we'll point out a couple of things here as we move along. So let's give this little puppy a spin, and what I'll do is I'll zoom in on the oscilloscope. So that we have a much finer and detailed view of what's going on. Alright, let's give it a spin. Ready to rock and roll. See the pattern starting to establish itself. It's about a 6,500 RPM. It's drawing a little bit over 2.2 amps, and we have a 24-volt input to it. Now, what we're going to do next is I'm going to freeze this and point out a couple of things for you. So what you note here is on screen you have the yellow spikes, that's the voltage, and the blue is the amperage value. If you take a close look at it, you'll see that the pattern is a little bit irregular. One of the interesting things here is that the rise time when the machine fires, that voltage spike is almost instantaneous. It's right up there. However, at the 0 point for the amperage, the rise time between this and up here is approximately 700 milliseconds. It takes a little bit of time. You'll also note the amount of hash, the back EMF right here. There's quite a bit of it being involved. So I think that gives you a perception of what's going on as far as the motor is concerned. I can't allow it to run too long because the transistors on the switch get very hot very rapidly. You have about 2 minutes of runtime. Before it starts getting way too hot, the transistor temperature will rise up to 180 or 200 degrees Fahrenheit. Anyway, we just shut this down. That little wave pattern at the end is the generator effect produced by the neos running through the coils, the back EMF. The basic, I think I've done everything that I wanted to show. Next one is going to be the series coil version, and we'll also run that at 24 volts just as a comparison. So again, just to reiterate, about 7,200 RPM right now, roughly 2.1 amps at about 24.7 volts operational. So there you go. Thank you for watching. See you next time.